Hello, chemistry students. This is some practice on drawing IMFs or intermolecular forces. And just remember that intermolecular forces are on the outside of molecules. And when we're talking about intermolecular forces, we're talking about dispersion forces, dipole interactions, and hydrogen bonds. They are weaker than the intramolecular bonds. Those are nonpolar covalent bonds and polar covalent bonds and also ionic bonds. And so the intermolecular forces are weak while our intramolecular bonds are very strong. So I wanted to make sure that you know the difference between the two. So intermolecular forces are on the outside of molecules. Intramolecular forces or bonds are on the insides of molecules. So make sure that you know the difference. What we're going to look at here are the intermolecular forces. What keeps molecules together, like attracted to each other, not what's holding the atoms together inside, what's holding one molecule to another molecule. So let's first look at our dispersion forces, which we have here. And I already drew them out for you just so that I wasn't messing up with the screen and everything like that. But dispersion forces are going to happen between temporary dipoles. Temporary dipoles are non-polar molecules that have electrons that are constantly moving and shifting around. And so above the arrow with the red circle, you can see that I have my temporary dipoles in pink. And if you look at them, like you can see that some of them have the signs have changed places because our electrons are moving around. So, for instance, like this is temporary dipole number 1, and this is temporary dipole number 1. So you can see that the charges changed sides because the electrons have shifted. And the same thing goes for temporary dipole number 2. So above the arrow, you have the positive sign on the right, but below the arrow, you have the positive sign on the left, again, because your electrons have shifted around. And then here in the middle, here's our dipole, temporary dipole number 3, and here's temporary dipole number 3. And for 3, it hasn't shifted. So in this little snapshot, it remains the same. But with the temporary dipole, the negative side on one molecule will be attracted to the positive side on the other. So above the arrow, I have temporary dipole number 1 is attracted to temporary dipole number 3, and then below the arrow, after the electrons shift places, I have temporary dipole number 2 attracted to temporary dipole number 3. Whereas like over here, like above the arrow, 2 and 3 are going to repel because their negative sides are close to each other. And then below the area, 1 and 3 are going to repel a little bit because the positive ends are going to repel each other because they're close by each other. So this is what makes dispersion forces very weak. They are going to be constantly changing. They are not permanent. Dispersion forces, however, are going to exist among all molecules. So if I ever ask you, like, okay, you've got molecule A and B, what kinds of intermolecular forces exist between them? You should always say dispersion forces, and then you have to kind of look at the polarity of the molecule and at the structure in order to determine, is it dipole interaction or is it hydrogen bonding? Okay, let's move on to dipole interactions. Dipole interactions are different from dispersion because they occur among permanent dipoles. These are permanently polar molecules. So no matter how the electrons move, one side is always positive, the other side is always negative. Like that's not going to change. And so the if this is permanent dipole number 1 and 2 and 3, you can see that the sides of the molecules that are oppositely charged are going to be attracted to the oppositely charged sides of its neighbor. So permanent dipoles, dipole interactions, because they occur between molecules that are permanently polar, they are going to be stronger than dispersion forces. Are there dispersion forces at work here between these permanent dipoles? Yes, yes, there are. But so like if I asked you like between numbers 2 and 3, what forces exist, you would say dispersion forces and dipole interactions. Our last and strongest type of intermolecular bond isn't really a bond at all. It's more of an attraction. They call it hydrogen bonding, though. And this is going to occur on a molecule where you have a hydrogen that is attached to a very electronegative atom. And so this can be a fluorine, an oxygen, or a nitrogen. So you have to have a hydrogen attached to fun. Now look it. I know that fun is not spelled F-O-N, but go with it because it's going to help you to remember. So you have to have a hydrogen and you have to have fun in order to have hydrogen bonding. So what's going on here is that the hydrogen on one molecule is attracted to the unshared electron pair on an F, O, or N on a neighbor. And you can see the purple squiggle here. That is representing that attraction between the hydrogen here on molecule number 3. That's my little pink arrow, or my little pink molecule, atom, excuse me. And it is attracted to the unshared electron pair on molecule number 2. So for hydrogen bonding to occur, yes, you need a hydrogen, but the hydrogen has to be attached to a fluorine atom, an oxygen atom, or a nitrogen atom. If it's attached to anything else, like if it was like HBr, for instance, then this would not undergo hydrogen bonding. Is my hydrogen attached to fun? No, it's attached to Br, so it doesn't count as a molecule that could undergo hydrogen bonding. So that's how you would draw the interactions between atoms and demonstrate different intermolecular forces. Remember, intermolecular forces are weak, intramolecular bonds are strong. All right, I will see you again soon. Bye-bye.